I'm James Long. I work for Mozilla. I help developers write web apps, and on the side, I contribute to projects like Sweet.js and asm.js. And I pretty much like anything that has to do with low-level compiler stuff or just cool stuff. So if you go to my blog, you can see other stuff that I work on. So I'm going to talk to you about Sweet.js. Sweet.js is a macro system for JavaScript. It started at Mozilla about 2 years ago. An intern named Tim Disney started it, and he did some fantastic work throughout that summer. He essentially was able to prove that this is possible. In the past 2 years, we've seen a whole lot of amazing contributions, amazing features. We've pretty much been able to just blow through a lot of academic papers and implement a lot of really cool stuff. So it's working really well, and I've personally been impressed at the positivity of the reactions, because usually macros have kind of a bad reputation, and a lot of people have this weird taste in their mouth of them. But people seem excited about it, which makes me excited. A few months ago, I wrote this blog post, Stop Writing JavaScript Compilers, Make Macros Instead. So if you saw that post, I was the one who wrote that. And I was blown away, again, by the positive reception. It got pretty popular, about 50,000 views. There were some negative comments, which is constructive and good. But it proved to me that this is something that people want, and is something that really will enable you to do some awesome things in JavaScript. So let's dig into it a little bit. I think Sweet is a perfect name for this, because it either gives you the vision that you are drinking the sweet fluid of JavaScript and macros, or you're on drugs. So when it takes, there are a few phases that your program goes through as you write code and to make it do something. It needs to be parsed, it needs to be compiled, and it needs to be executed. Macros add another phase to this before all of that happens, the expansion phase. And this basically allows you to tell the system certain patterns of code that you want to take and turn into something else. And then the compiler or the system will take that new code and then run through the last 3 phases. So essentially, it enables you to do things like this. You can tell the system, hey, when you see a var keyword and there's an object literal on the left-hand side, I want to turn that into 2 var statements, which declare the variables x and y and set them to pos.x and pos.y. I'm sure that you recognize we essentially just implemented abstractly a basic variable destructuring, which is in ES6. Of course, I'm sure that you will also see that the first form of code is not valid JavaScript. But because the expansion phase happens before any parsing, before any compiling happens, we can take things that are completely invalid JavaScript and turn them into things that are valid JavaScript. So if we take a little bit of code, this is just a function that replaces a space with dashes, and then we call it. We're used to looking at it like this. We kind of load this into our head, and we simulate it in our head. This is how we typically write code and read code. And this is how we should write and read code. But we see that getName is called, dashify is called with the result, str.replace is called within dashify, and then the result is passed to display name. We're trained to read code this way, and most of you all should read code this way. If you're a compiler writer, you typically look at code a little bit differently. And it's true that you could say that macros are essentially hooks for little mini compilers. But it's actually much more than that, which I'll go into. But let's look at this syntactically. What does this actually look like? Well, there's the function token, then there's a dashify token, then there's a left parenthesis, then there's stir, then there's a right parenthesis, et cetera, et cetera. So you can kind of see this syntax as one long list of tokens. Real good macros are actually much more than just operating on a list of tokens, though. It wouldn't be that hard to somehow implement something in most languages that give you hooks into the compiler process, where you received either a raw list of tokens or a raw AST, and you mingled it, and then you return it back, and then it kept on doing it. That's not very interesting. It turns out in real-world practice, that's incredibly hard to work with, introduces all sorts of bugs, and just really doesn't work. So a good macro system knows a little bit more about the code than just the syntactical structure. So Sweet.js knows about things like variable declarations. So it actually knows the scope of every variable. It knows about things called delimiters, which are any parenthesis, any curly brace, or square brace. So Sweet.js actually works on a nested tree structure. It doesn't work just on one long list of tokens. Essentially, it works on tokens, but there's a very lightweight tree. So what we get is this lightweight AST that Sweet.js can work on. Now, when I say AST, it's still really not even an AST because it really doesn't represent any of the true JavaScript semantics. It's not grouped by semantics. It's grouped by structure. And this means that we can still do all sorts of things that are invalid JavaScript and turn them into valid JavaScript. So this is what a macro definition looks like. This is a macro do, and you have, for the Sweet.js macros, you have a list of rules, and within those rules, you use pattern matching. So so this is the first pattern in the rule. So it checks to see if it matches this pattern, and if it does match a pattern, then it expands to the code inside the rule. And so if we invoke do, the first thing it does is it checks if the left curly brace matches, which there is a left curly brace, and then it checks if there's an expression within the curly brace, and there is, and then it checks the right curly brace. So it correctly matches, and it returns this call to _wrap. If it didn't match, it would throw a not matched error at the expansion time. And so that's a very high-level overview of how you define macro, how the macro expansion works. We'll get into more details of the features. So with this macro system, we've added this new phase, expand, and we've added a way to define your own abstractions with macro. This is very important because the keyword function is actually a really, really important thing, and I think we kind of take it for granted sometimes because if you look back at some really old languages, it was actually incredibly hard to build up your own abstractions. Function allows us to take built-in APIs, built-in primitives, as we're doing a set of instructions. Function allows us to group those up into a small unit of functionality that we can reuse throughout our system. We do this all the time. When you sit down to write a project, you write tons of functions and you create your architecture. If it weren't for function, we wouldn't be able to write any sort of complex system at all because you'd have to constantly be dealing with implementation details. Macro gives us the same thing syntactically. And so now we have hooks on both ends of the process to implement really interesting features. So syntactical abstraction and functional abstraction allow you to do far more things than you could before. And you could argue that this is terrible. I will get to those arguments later. In the grand scheme of things, you should still be writing a lot more functions. You shouldn't really be writing a whole lot of macros. But the ability to have the syntactical abstraction unlocks the language from the virtual machine version and makes it much easier for the language to evolve. And I'll get into why that's important for JavaScript too. So let's dig into the actual Sweet.js macros. How do you actually write macros? What are the features that enables you to do things? So this is a basic macro again. This is a macro foo. So there's one rule, and the identifiers that are prefixed with a $sign are called pattern variables, pattern matches. So it basically binds whatever syntactical structure is at that place to that variable that you can use within the rule to emit the same syntactical item. If you don't prefix it with $, you'll see plus does not have a dollar sign. It will match that literal word. So you can see that I call foo with 5 plus 6, and it matches plus, and then it binds 5 and 6 to x and y, and it returns the 5 plus 6. So that's how you can introduce literal words, and then you can also use the dollar signs to bind whatever is in that place. Macro names can be anything except any of the delimiters. They can be anything except for parentheses or brackets. So we could actually define a macro named foo arrow if we wanted to. If you use multi-tokens, which is essentially multiple of the like symbols, like equals, and if you use a list of those, you have to wrap it in parentheses when you're defining the macro name, just for various reasons. But this defines a macro name named foo arrow, so you can do like just the arrow macro, which lets you implement the fat arrow syntax, which is in ES6, and you can do a lot of other interesting things like that. So this is a macro which defines multiple patterns. This is where it starts to get really powerful, because if it doesn't match one rule, it will just walk to the next one, and it will just continually pattern match down. If you ever use any kind of pattern matching, you're probably used to this kind of workflow. So you can see that this macro foo will accept an arrow and then an item, or a literal array syntax with one item inside of it, or just anything. So if we call foo with the arrow bar, it expands it into, it calls it the function arrow, passes bar into it. If you call it with a literal array with one item bar, it will expand into a function called array. So this just is showing you a very, very basic example about how you can use multiple rules to generate code conditionally based on the syntax. Another feature is pattern classes. This allows you to tag a pattern variable and tell the system a certain type of syntax that you want to match. So there's built-in pattern classes ident, lit, and expr. Ident basically says any sort of identifier, which is essentially any kind of word, maybe it has an underscore in it. Any valid JavaScript identifier will be bound to this. Lit means a literal, so any JavaScript literal like 5 or like a number or a true or false, any of those literals will be bound here. Expr means any valid JavaScript expression, and that one is really important, which I will show you in the next slide. So here we have a macro which binds a literal to x. So if we called it with an identifier bar, it would actually throw a match error. So this lets you specify specific things to the system, which not only give you better errors, but sometimes actually indicate we could have multiple rules here, and the second rule could bind x to a identifier, so you could actually generate different code depending on whether it's a literal or an identifier. So this is the expr class, which binds to an expression. You find that you really want this, because essentially Sweet.js is just binding, working on a stream of tokens. And so when you just use $x, it doesn't know whether you mean if you call it with a function called bar, it doesn't know if you mean I just want bar, I just want the identifier bar, or if you want the whole complete expression of the function call. So by default, Sweet.js will bind on one token. So if you just use $x without any pattern class, it would just take off bar, and it would match bar to x. But since we've used the pattern class expression, we're telling it I want a whole valid JavaScript expression. So it's going to consume the whole function called a bar. And so you'll see with expr, this will generate bar, parentheses, the whole function call, and I can wrap that into something else in my macro. If I didn't use expression, I would just get bar, and you would generate a lot of code. And then after the expansion happens, you would still have some trailing parentheses, which would probably be a syntax error. A lot of the time, you really want an expression, so you end up using this pattern class a lot, which is very important. There's also let macros, which is another way to define macros. It's not really the ES6 let at all. This all happens at expansion phase. But if you define a macro this way, you say let and then the macro name equals macro. It lets you generate code that uses the same name that is the name of your macro. by default, macros in Sweet.js are recursive. So if you had a macro named foo and you generated code that invoked foo as well, it would recursively expand it until all of the macros are expanded out. The problem with that is if you wanted to do something like override a built-in keyword, like var or function, you couldn't get access to the built-in keyword var or function. So what you do is you define a let macro, and Sweet.js says, the var that I'm expanding to is not my var macro, it's the built-in var. So this is what lets you override built-in keywords. There's also repeating patterns. You basically use this with the ... This says whatever was preceding the ... I want to match as many of them as possible. So if you're inside, say, like a function body, it's going to match up to the end of the function body, because remember, we're inside this nested tree structure that's kind of a lightweight AST. So whatever level you're at in that AST, it will match up to the end of that. It's not going to match the whole rest of the file. So you can also specify an optional delimiter. So if you, with the parentheses, you can say parentheses comma, and that means that it's comma delimited, so there's commas in between each item. And that turns out to be really useful because then you don't have to worry about trailing commas and all that kind of stuff. And it will match IDs that are with commas in between them. You can also specify a complex pattern group, somewhat similar to regular expressions. You can like group them and then that match them multiple. So this is actually matching this syntax, some ID, and then the literal word as, and then some other thing that's bound to var. Match that whole thing with commas in between them, as many as you can. So this is a macro that looks like this. This is our do macro again, except now we've extended it to support multiple expressions. So now within do, you can comma delimit expressions, and it will match all of them. So you see that I'm using item with an expression pattern class. It will match a full expression, and then it will comma delimit them, and it will match all of those items. To ... them in the code that you want to generate, you use the exact same syntax. You use the optional delimiter plus the ... And it will take whatever amount that it matched and put it into the generated code. So here we've wrapped foo and bar, the function calls. This is a quick overview. I hope I'm not going too fast. Sweet.js implements hygienic macros. And there's a whole history of this that I'm not going to go into a whole lot. But because macros actually originated, well, I'm not sure exactly where they originated, but they were used widely in Lisp. This is kind of the Lisp claim to fame, is that they use macros and they're able to evolve and do all sorts of awesome stuff. The problem with a lot of those macro systems is that they're not hygienic. What hygiene means is that it tracks the meaning of variable definitions across your program and within your macros. And so it will make sure that there are not any collisions. So if you have a macro and you define a variable, if you expand out to code that defines a variable, it will make sure that that variable is only meaning what you want it to be within that code expansion. And if there's another variable with the same name that it happens to expand to in the same scope, it will rename those identifiers to make sure that they're renamed and unique. So if we have this macro, which takes an expression and squares it, it will, you can see that it's renamed this x to x $2, and then it's renamed the x that the user defined to x $1, and then it multiplies x $2 by itself. So it maintains the uniqueness of the variable, which is what you originally intended. This ends up being extremely important for real-world macros, because when it comes down to it, if you're writing a lot of macros, they tend to get pretty complex. So you tend to want to use temporary variables to maintain state between certain calls of the macro, and the ability to define these temporary variables without without collision guarantees then is very, very nice. And if you don't have hygiene, the Lisp world, I think, has dealt with this a lot. It's really just a headache. Turns out to be really, really useful for modules as well, because modules, we haven't done it yet, but Sweet.js should implement with the ES6 module system for JavaScript, so you can actually import macros from a module. We need to make sure that everything that's identified in those macros is still referencing the correct thing that was within that module. So hygiene is very important, and I'm not going to go into exactly how that works because it's a pretty complicated algorithm, actually. So another interesting thing is infix macros. So JavaScript, Lisp doesn't have this problem because it's all postfix or prefix. I forget. So, but JavaScript is all infix, and so you really need infix macros because there's a lot of stuff that you couldn't do if you couldn't do infix macros. I'm actually showing you the full macro that implements fat arrows. This is the full macro that's in my ES6 macros project. So it's pretty simple. And I hope I've explained the techniques so far clear enough to where this isn't shocking to you. But you define infix macros by using the bar. So that bar that's inside of each rule specifies where the macro was invoked. And on the left-hand side of the bar is when I want to match before the invocation of my macro. And then the right-hand side is just everything after it, too. You also have to say rule infix and just a rule you have to tag it specifically as an infix macro. So using this macro, you can see that we match any number of arguments in the first rule, and then they're going to be the arrow. And then when we match a literal curly brace, and then we match all of the body inside of it, and then we match the end curly brace. And if it's of that form, then we generate a function that accepts all of those arguments, just puts the body inside of this function, and then calls bind this, because that's the whole idea about fat arrows, is that this context is kept from the outer context for wherever that function was defined, that should be bound to this. So the second one matches, it's the fat arrow syntax if you just have one expression right after the arrow. You can do that without using curly brackets. And if you do that, it actually returns that expression by default. So you can see that there's a few different, I was hoping to show you a real-world macro, which helps show you the power of using multiple rules, generating slightly different syntax that lets you do cool things. So this is what you're able to do with that macro if you use arrow. This is the fat arrow syntax, and if you use this, then this will be bound for the outer context. I know I'm flying through these. This is the last thing I'm going to mention. I'm not even going to go into it much because it's really complicated. If you just absolutely can't do anything with the whole pattern matching system, which is actually pretty rare, you can use something called case macros. Case macros actually allow you to execute raw JavaScript. So you see that we use case instead of rule, and when this hits this code, you see there's a console.log. This is actual just real JavaScript coding here that's run at expansion time. So this lets you, there's certain methods in here to introspect what the pattern variable ID and var is. You can actually access the raw token list. So you can do anything you want to. The thing that case macros are mostly used for is breaking hygiene. So since everything is hygienic and we have the whole pattern matching and everything is automatically tracked with the right scope, there's no way to introduce a new variable. So if you wanted to write a macro that wrapped a body of code, but you wanted to say the variable ID is defined as a specific thing inside that body, you can't actually let the user access that variable with just the normal rule macros. But with case macros, there's certain functions to let you break the hygiene. It's actually frowned upon. You rarely should have to write case macros. There's just a few cases that are useful for that kind of a thing. And I'm not really going to go into all the methods and different ways to do that. But just I thought it was worth mentioning. So there's a whole lot more. I didn't want to dig too deep into it, but it's hard not to. You kind of have to go through enough to show you what it can do. But there's custom pattern classes. You can actually write your own macros and invoke them as pattern classes. There's macro generating macros. There's recursive macros. There's all sorts of patterns for matching all sorts of complex code. But it's really cool. It's a whole lot easier than writing compilers. That's for sure. And it's also far more composable because of the hygiene and because of all these other things that the system knows about. Because if you write multiple compilers, the compilers don't compose. That was what my original blog post was mainly about. Whereas if you write a compiler that extends the syntax in a certain way, your second compiler that does something else can't parse the original syntax that you extended. macros allow you to do all of this. I've written some tutorials on my blog, jlongster.com, so if you're interested in this and not such a rushed walkthrough of Sweet.js, I'd recommend going to my blog. There's 2 tutorials up, and hopefully that will be a little bit better explanation about what's going on. So to use this system, it's really easy. You just npm install Sweet.js, and you call the sjs compiler. If you pass -c, it generates source maps. So this is another extremely interesting or extremely important part about Sweet.js, which is that it guarantees that you're going to have source maps. So every single macro that you write, you will always be able to debug your original code. Whereas if you're using ad hoc compilers and stuff like that, you'll find the source map support is usually pretty lacking. But this ensures that you do have source maps and that the debugging is actually very natural, whereas most of the browsers these days are supporting source maps, which is pretty awesome. So I'm sure some of you are sitting there and being like, well, hold on, can't you implement some really weird syntax? Isn't this a little bit too powerful? Aren't there going to be some really weird things that people do? I mean, you should never ever be able to assign up to a function call. And what is that dash even doing? I mean, people are going to be doing these things that are what the heck is going on here? And yes, you could do this with Sweet.js. And we've already seen people do these weird things where they're trying to do Ruby do notation. Sorry if you're that guy, but these are things we shouldn't be doing. There's a whole decades of culture in the Lisp world and a few other languages that we can look at to see what the right way to write macros is. I think in Common Lisp they had I don't know a whole lot about Common Lisp, but as far as I know, they kind of got into a culture where it's okay to write lots of macros, and that's actually not right. You really shouldn't be writing a whole lot of macros. But if you look at the Clojure world, I think they've been able to establish a really good culture, which there's macros used for the really powerful features by the people who know what they're doing, usually internally, and they're released as a library and in the core.something. And you can just include that library and use it without having to upgrade your version of Clojure. But when you go and sit down to write a project, you should not go and sit down and write 10 macros. That's ridiculous. So there are a few problems. People might abuse it. There's syntax highlighting problems, and some people don't like a build step. Hopefully in 10 years, my goal is to have macros natively in JavaScript, and I'm backed by Brendan Ike on that one, I think. So there's some legitimacy to that. But really, here are my rules for writing macros. First of all, don't write a macro, because if you don't know why you're writing a macro, then just don't write a macro. And if you're really going to write a macro, don't break JS syntax. Don't go and if you're tired of curly braces, you should just be using CoffeeScript. Don't write macros just to get rid of the curly braces. The macros really just enable powerful features like variable destructuring, all of these ES6 semantics and things like that. And personally, I think if your macro can be used as an expression, if you expand out to code that is still an expression, I think it's okay to use it as a parenthesis, which looks like a function call, but it kind of expands it out to something else. And if your macro is going to be used as a statement, then you can kind of invoke it with a curly brace, and it just makes it look a little bit more nice. Syntax highlighters mostly will deal okay with this. If you're using something like JSHint, things like that, that is a problem, and I think that there are some solutions to that. Maybe extensions to those things that you actually implement your own little patch to those. I'm not sure how that looks yet, but if you really don't want to enable macros in your project, but you want to use them, if you're afraid you have an engineer that's really overzealous, then you could write a macro that actually disables macros. So this lets you use macros, npm install the macros all you want to, and use the really cool stuff, npm install ES6. But if you're overzealous college graduate, goes and thinks he's going to be cool and write macros, he'll just get an error, a syntax error. So this is a case macro that's run at expansion time and throws a syntax error and tells him that he's foolish. So I think we can look at things like Clojure. I've been really impressed at their core async library because they were able to release this library and people were able to use it immediately. And this essentially implements something similar to generators. At least it's a lot more powerful than generators, but the essential technique is similar to the idea of generators, where a function can be paused at any time. they were able to do that completely with macros, so they release it completely as a library. And I think this is the direction that I would love to see JavaScript going. We need to get out of this standardization process, which takes decades to get simple things like variable destructuring. There's no reason we need to wait for that when it's such a simple macro, which I've already written in the project I'm going to show you. There's so many things in ES6 that we can implement as macros, and that if people were used to macros, and if we had macros in JavaScript more natively, then we could go ahead and just use them. So that's my goal for Sweet.js. I think that's kind of Mozilla's goal as well, to help liberate JavaScript from this process of standardization, which typically is longer than other languages, especially because JavaScript is the mostly widely used language. It's the only language I know where there's at least 3 or 4 extremely competitive implementations of JavaScript. So you can imagine why the standardization process is a little bit slower, because you have to work with all of these vendors, all these implementations to make sure. And then we can't even, once they're standardized, we can't even use them until they're actually implemented. What if we took control of that? What if we actually implemented them as macros, not only had to not wait for them to be standardized, but could actually use them immediately, and then push them into standardization? We could actually test our ideas, test our structures in real-world code, instead of relying on the ECMA committee to make those decisions for us. So just a quick thing, if you want ES6, I wrote a project, ES6 macros. It has destructuring, classes, fat arrows. I wrote a macro called define record, does static allocation. It actually lets you use types, and then it compiles the accessors, like foo.x and foo.y, down to just references into a floating point typed array. If you want pattern matching, one of the core contributors, he's an awesome guy, Nate Falman, wrote this pattern matching macro, which lets you define a function and just define patterns. If you want better React.js syntax, if you want generators, you could even do that. So that's the extensibility of macros, and I think it really does improve the story of JavaScript. So that's it.